today's lesson is the first learning target of our new unit, which is about simple linear equations. So the first learning target states that I can translate sentences into equations and equations into sentences. So this one is very similar to the first learning target of the last unit that we did, where we were taking algebraic expressions and putting them into verbal expressions and then vice versa. So here we kind of need to first start with what is an equation. So by definition, it is a mathematical statement that consists of two algebraic expressions that are set equal to each other. Okay. So an example of that would be like if I had 2x plus 10. That's one algebraic expression. Another side that said 9 minus 3x. And then in between the two, you had an equal sign. So you would read 2x plus 10 equals 9 minus 3x. So this is an example of equation that you might see in the next unit, or like a more simpler one that we'll get to this unit would be 2x plus 4 equals 12, or x minus 9 equals negative 6, something like that. And so these are the type of equations that we'll be dealing with. Also remember that like the number 12 and number negative 6 are algebraic expressions. It's okay just to have one number on one side, just like it's okay to have multiple things added or subtracted to each other on another side. Okay, so let's go ahead and kind of check these out. So first, we're going to write a sentence for the given algebraic equations. Where we see, we're going to use a number for where it says x. Okay. So for this one, and when it says 2x equals 15, just like as it reads, except when there's just a 2x, remember that in between those is a multiplication sign. So I would write this sentence as 2 times a number equals 15. Okay, now the new thing to deal with here is the equal sign, and what we could use for this. When we did the card sort a long time ago for the first unit, we had equals in there, and so equals was a good word. The same as is another good one. Okay, and I'll use that here, so just keep that in mind. Another good one is the word is. So if something is something else, that means they are the same. So like for example 2 here, if I have x minus 6 equals 4, then a number minus 6 is 4. Okay, so the word is sets that up for us, makes the equal sign happen. This next one, I could say the product of 6 and a number take away 15 is the same as 45. Okay, so is the same as works there. Okay, so those are like the three options, and you can kind of rotate through them. You can use the same one every time if you want. I mean, is pretty equal or easy to write, but just so you know that you have those options, whichever one makes the most sense to you or fits the best. Okay, now we got some more complicated ones here. So x cubed plus 2x equals 7. So a number cubed would be a good one, okay? Or to the third power, added to 3 multiplied by a number is 7. Okay? And remember also for all these, because we have all these different words, there are lots of different sentences that you could write. So just know that I'm writing one way for most of these. You have different options. So if you see different or want to use different words, go right ahead. There's nothing that's going to be stopping you. Okay? So example 5. We have 17 equals 25x squared plus 2. So starting with 17 is the same as 25 times x, a number, I should say, not x, a number to the second power increased by 2. And just know that I'm trying to be creative with these as much as I possibly can to show you all the different possibilities that you have at your fingertips for these problems. Okay, then this last one we can say, now you could say 3 divided by 2 if you wanted to, but a shorter way is 3 halves. Of a number, remember of means multiplication as well, decreased by a number to the power of 4 equals 132. Okay, and so those are just some possibilities there. There's plenty of examples. And remember also, if you wrote it differently than me in the notes, that's perfectly fine. Like, there's nothing that says you have to write it the same way as me. So then now let's move on to the last set example. So going the other way. So we have a sentence and we want to write it in an algebraic equation. Now I probably have this flip-flop, but where you see a number, you want to use the variable x for these. If it didn't state that, you could use whatever variable, but we're specifying for you to use x, which is the most common one anyway, so it just makes it easy. So example 1 says 7 divided by a number is 5. Now when you're going through these, there's really only one answer for them, okay? So it's nice to, like, underneath the word to describe what operation or number there should be. So divided by is a division sign, a number, we can use x. Then you got is equals, and the number is 5. And maybe I could write that a little bit better for these. So it's a division there. Okay? So now you just kind of want to put those together. So 7 divided by a number, I could literally just have those symbols there and write my answer. You could also write it like 7 divided by x equals 5. You could write it as a fraction. Here there's different ways of orienting it, but you need the division in between the 7 and the x. Okay? 15 times a number less than 80 is 25. So here, I see 15, I see 80, and I see 25. Okay, all numbers. Okay, I see an is, so that means equals. I see a times, so we know that's multiplication. I see a number, so that should represent x. And I see less than, which is subtraction. Now, another thing to note with the word less than is you switch order there. Okay? So normally you would probably think 5 times x, so 15x would be minus 80 equals 25. But in that case, so let's visualize that. But in this case, these two need to switch around the minus sign. So the correct answer is actually 80 minus 15x equals 25. And that's the correct answer. And notice here, there's only one way of writing that. I can't really find a unique way like I did at the top, for example 1. Okay, let's scooch up. So example 3 says 2 plus the quotient of a number and 8 is the same as 16. Okay, so I see the number 2, 16, 8. I see a number, so let's say that's x. Okay, now here the same as, that'd be equals. I see a plus sign in there. I also see the quotient of. Okay, so remember that means that in parentheses, I'm going to have division. Okay, because the quotient is the result of a division problem. That's what that word means. And where that goes, or the division needs to go in between these two things after it. So it's kind of saying, these are what I'm putting in parentheses right there, is a number and 8. So I need my division in between those two. So my problem should look like 2 plus parentheses. There's my division. So the first thing that's said in that statement goes on the top. The second thing, so first, second, so the second thing goes on the bottom. Okay. Just move my arrow so I can write my answer. And then equals and 16. So that's my answer. Okay. All right, and then the last one here says 27 times a number is a number to the fourth decreased by 5. So here I see that it's 27. A number means x. I see 5. Now I also see 2 the fourth. That would be an exponent of 4. Okay. I see a number again. So I have 2 numbers. And then I see the is there. So that would be equals. I see times. And I also see decreased. So subtraction. Okay, so Now, sometimes it's nice to like place where your equal sign is too, if there's a lot going on, and start there. So then the things to the left of the equal sign that you stated are on the left side of your equation. The things on the right side of the equal sign in your sentence are on the right side of the equation. So things on the left, it says 27 times a number. Well, I would say that it just looks like this. So 27x. Or you could put a dot in there, parentheses around the x, however you want to show it. And then on the right side, it says a number to the fourth decreased by 5. So x would be a number that's to the fourth, so I would put to the fourth as the exponent of x. Decreased would be the subtraction sign that I'd put next, and then the number 5. So then that's my answer. Okay? So it's always good to kind of locate things, map them out. And what I was doing on the problems here was like notating the things I saw so that I could kind of put them all together into one equation. It makes it easier when you like notate and draw, like kind of locate things that you see so that you can kind of separate those from the things you don't see, and then you can concentrate more on the things that you're like, oh, that means something, and then you're able to look it up, because at first glance there's a lot going on in the sentence, but once you get through that, then it makes it a little easier. Okay, have fun.